Welcome back to Daily Standup, and I'm going to report progress on my research database providers ticket. So we went over this last time. I left it in progress just because I felt like I still had a couple things to look up about it. One note that I'm going to add here is a new note for my migration framework that I chose to go with. So I'm going to use Fluent Migrator to handle the migrations. Basically, whenever I deploy my application, assuming how you have your architecture set up, I need a way for my database to also be updated, as I update my application. Because let's say that I add a new column or something, I alter it in some way, I need a migration script to basically update that for me, right? To execute the SQL necessary to update that. Or if in the event I have to roll back to a previous deployment, I need a respective down script to remove the change that I added in my up method. I can't remember if we went into that too much. Maybe we did. Okay, it's Fluent Migrator to handle migrations. I'm going to put this in a note here because I started to do the work anyway. Like I started to actually perform implementation work. Started to perform migration implementation work using Fluent Migrator. Okay, we can leave it at that, and I'm going to move this research ticket to done because I believe that we have everything we need, at least for right now, that I feel like we have a path forward. We have selected a database. Okay, so no real tickets are going to come out of this research I defined, but I think we are going to have some tickets. The reason that I didn't specify to create tickets in that one is because I didn't feel like just identifying a database would kind of warrant like actual implementation tickets. Using the database, I feel like that's more of a back end kind of discussion that I feel like we already kind of have that will be brought up. But there is a couple things that I feel like we need to do. One of them is I want to research back-end architectures. So if I can go into this a little bit right now, I think it'd be productive. So let me just done when. So the what really is I need time to investigate back-end design patterns. And one thing I'm going to call out for this is that typical back-end for .NET web applications that is utilized is often just okay. You have your some view, you have your controller, your service and repository, and that's kind of the general gist. Now, there can be design implementations in that model in terms of how those are going to be called. Is it going to be some kind of event-driven architecture? Is it going to be a subscriber-based architecture? Are we going to have a queue in there? But the overarching design of that, I believe, still largely stays the same. And if you learn that design, and if you go somewhere, you'll be able to pick up things pretty quick. And it's just that's really what it is, right? It's a way to build these pieces that we can identify. If we see repository, we're going to know what that is. If we see a service, we should know what that is. Although sometimes services get a little mixed up with actually making the database calls and things like that. Then they kind of grow into a huge file, and that's exactly what I'm trying to avoid. Is I don't want to make all this like spaghetti code everywhere, right? Because why? Then you're left with the question, well, why don't you just put it all in the controller and then have a one file backend? Which nothing is stopping you from doing that, except that it's not really good practice. You can make it work, but if the next person behind you, they're not going to know what's happening, and then you're going to have this huge mess that's going to grow to thousands and thousands of lines on a single file, and that's just not maintainable. It's not good practice. So I'm trying to think of ways where I know I have a general idea of my core functionality of my application for the handling the engine performance analysis, handling the actual saving of the engine configuration for the user, and also I need a way to handle I don't want to call them like subscription events, but basically just syncing. It's like general syncing events. Like when I save the engine data to the database, what happens? Am I getting a response from the database back? Am I going to sync the front end with any kind of notification that it succeeded? Am I going to trigger another method after that, as far as like, hey, then run the engine save configuration through some kind of analysis strategy that makes suggestions based off numbers and previous configuration, which is where I ultimately want to get to. So I don't want to like back myself in this corner of I made this one way route in my code that'll make it real hard to be modular after the fact. If I then want to go in and add all the social features I want to add in and all the possible learning features I want to add in too, using some kind of data modeling system. So I'm trying to think of ways that I can make this modular in the sense that I maintain a very very linear path in the code, but there's interchangeable components, and it's very composable, meaning I don't have to explicitly specify a return value and then pass that through. It'll just be passed through naturally. So making the methods composable. And I'm really trying to think about this because I want to explore potential new options that can make me better as a programmer, but also just open up a door for learning maybe a new pattern, and one that I've put a lot of thought and time into. So the one I'm thinking of investigating that I seriously would like to learn about more is one called is through the use of data pipelines and data meshes. So it's heavily inspired by just really core data structure techniques. Like if you think about traversing a tree, you have the root node, and then you go down each node until you hit whatever leaves you have, which is a node with no children. But there has to be decisions of, okay, do I go to the left or right node? What happens if there's no left node? What's the maximum depth, and everything like that? And if we want to go back, reverse back up the tree, how do we do that? And that's kind of how I want to look at this problem, because I really have a pipeline going here, because we have the front end, which, well, okay, I'll write this down. So possibilities include the use of I'm not going to spell this right, propagator block. And I'm just going to put transform block in there because I'm be using both. Queues. And, well, okay, I want to be more specific because I am actually buffer block is what I'm leaning towards. Actor models, and let me go into more of, so propagator blocks or transform blocks, as I'm going to refer to them, because that's another that's how I'm going to encapsulate all the propagator blocks. Or sorry, not, I said that reverse. Propagator blocks are going to encapsulate the transform blocks. Basically, it offers, transform blocks are basically strategy that allow you to specify the source and the destination and provide functions or that provide functions to do that. So if you've looked at, I'm referencing my Medium article that I wrote on this. You can kind of see what I'm kind of thinking for this in terms of this code right here, where I have this multiply, add, and divide block, and then you can see I link a block to the next block, and then so on, and then you can encapsulate that in a data flow block, which is the implementation of an iPropagator block, and then it encapsulates all that. But then the only thing you have to do to call that is you can say you can call your propagator block and then call .post or .send async, whatever you're depending on if you want to do it synchronously or asynchronously. I think I'm gonna do it asynchronously. So I'm gonna use async or send async, and then you can call receive async to actually receive the value back from there. So nothing is blocking. And the big benefit you get with this is since you get a pipeline, you can pass a token all the way through. So at any time, if you need to raise an exception, you can basically cancel the token. That will stop and then raise the flag to wherever you have it set up to be. So that's a really powerful strategy, and it allows for easy use of concurrency if you want to make these things run in parallel. Because let's say I have another pipeline that I need to do the same thing, right? Like if I have a use of, I have this saving or this syncing pipeline, which I know what to do. But let's say I also have this update feed pipeline running at the same time, and I want to have them both go, and they're not, these things are mutually exclusive. They don't have to, they don't depend on one another. Not mutually exclusive. One doesn't depend on one another. So if I want to have those running at the same time, this will give me the flexibility to do that very easily because they're already all contained. So really it's just a matter of calling those blocks and then setting it up to run in parallel, which they already kind of in their nature through propagator blocks is already set up to do. So I think this is going to be really powerful, and it'll allow me to write a little bit cleaner code from the endpoint side of things because I'll have an endpoint. I'll be able to post data to the endpoint, and I should, in theory, be able to specify which block I want it to use by value, an enum, string, whatever, and then it'll take that route down. And I think it's going to be really clean because I'll in theory be able to set up the sync pipeline, which I know I need. So it'll be kind of like this is just going to be rough pseudocode. Receive data, transform data, and save data, and then share data. So that's kind of the rough pipeline that I need. So each of those can just be a link to the next block, and then it makes it really easy because everything's composed and I'm just passing the return value to each of those, and I'm not having to worry about any messing with the data structure at all or whatever. But it's nice because each block will then know what we'll have like a knowledge of the previous block too, which I think is powerful. But then this is all self-contained in the sync pipeline, so I'll just be able to, once I establish my I'll have the social pipeline, so that'll be kind of like you'll still need to receive data, you'll still have to transform it in some way, but now we're going to I'm going to change that from share to analyze data. We're going to share data and then recommend data, okay? And you can see some commonalities between this just off the pseudocode. The receive data is probably going to be the exact same thing. It's probably going to be receiving the engine model that we've set up, which is an aggregate of an aggregate of several of my DTO objects from my database. So that'll be self-contained. So we're going to receive engine model, okay? And the powerful thing about this is because that they probably are going to be the exact same. We're going to have to receive it anyway. But again, these are running, independently, but using similar parts. We should be able to swap these blocks and share the blocks, which I think will be really powerful. Again, it's all a matter of just you make the block once, and then you specify link to the next block, and then the source, and then return value with the func, and it should just work. So I really think that this is a promising solution that I could use for what I'm trying to do, at least within my application. Now, there'd be some. Obviously, this introduces a little bit of complexity over just having 5 or 6 or a few endpoints, and then having a bunch of different services and things like that. The problem with that is that's really more of the traditional approach, and I'm really trying to, I feel like, kind of explore another option just over that in terms of readability, testing, and everything like that. Because if everything is a block, it's going to make it really easy to test. And I'm not going to be using any kind of shared state. I'm not going to be I'm not going to be passing like a bunch of properties that could be mutated in another spot, and then so I'm really going to try to keep it as much as I can with of like a pure function as I can. So whatever inputs it receives are is going to determine the outputs. All right, there's not going to be I'm trying not to have too much shared state for all this stuff. That just makes it harder to track. So that's what I'm thinking for right now, at least for the specifically the back-end side of the application that's going to be contained in the application itself. And then another possibility is going to be through the use of a buffer block, which is just a first-in, first-out queue in .NET. That is also can be asynchronous as well. And I'm thinking, I haven't landed yet on fully what this is going to look like, which I think again warrants this research back-end architecture, which I might just do a architecture meeting, a design meeting on the channel, because I think we really need it just to be able to talk through and think about, okay, what is this actually going to look like? And then obviously we're going to have to model it and draw everything out. So the buffer block, I'm trying to limit any kind of blocking calls. And originally when I was thinking through the design, especially for the live engine simulation, I envision that there's going to be quite a few calls to the back end happening. So I may need to throttle that in a sense, or not throttle, but handle it better than just waiting for a response back. So I think I'm going to need to use a queue to handle the engine simulation, because there's going to be a lot of calls to the back end. I haven't determined how many yet, but there's going to be a lot. So there's just going to be a lot of headless calls to the back end. So all those requests are going to need to, I think, be loaded into a queue. And then I'm going to need to have some kind of processor that's acting on this queue, whether I have something listening to a message posted to the queue, and then it receives and then returns back. I think that's what I'm going to do. So listener to queue. And you could definitely argue that the queue or this kind of structure may warrant a separate API outside of my hosted application, and I could definitely see that being the case. It's just that would add a lot of complexity pretty quick before I even get the application launched, and I think that move would really be more of a architectural refactor once the application is deployed, if that makes any sense. Because going that route initially, prior to kind of investigating performance, just using a kind of like a queue just right in the .NET application itself might be a little overkill, and it might add a little more time that we don't have for this. And honestly, making a refactor to an externally hosted API or some kind of serverless function wouldn't be the hardest thing to do. It's just I don't know if we need to take those steps immediately right now. So I think I'm just going to do it this way. The actor model I haven't explored yet that much, but I'd like it to be a point where I at least give some thought to. But to go back, I guess, to the queue. So the reason why the engine simulation needs a queue is because that I want it to be as close to real time as it can be. But in other senses, you have to ask, what value does an engine simulator add beyond just the educational value that you get seeing the engine components work together and numbers and things like that. The value is really going to be, I think, in the analysis, and I think in the kind of the general sharing of user data in terms of like a socialized approach to engine data. Meaning, I'm trying to think of, because I haven't fully fleshed it out yet, but I really think we're going to be sending a lot of backend requests with real-time data that we're seeing, and we're going to need to house those requests in somewhere, or just a general housing of state somewhere, because we'll need to see, okay, what does the engine look like with this configuration versus what does the engine look like with this configuration? What kind of numbers and variables are we actually seeing? So we're going to need to use a queue, and basically the problem we are trying to solve is, how do we handle a lot of requests sent to the backend with various states of the engine. Various states of the engine. I think it's a little bit still abstract right now, but that's kind of the general gist, right? If we update the engine, or if we're posting the engine data every 5 to 10 seconds, that's going to be a lot of requests, so that needs to go somewhere, right? So I'm thinking maybe like 2 to 5 seconds we post a request to log the engine performance. So I think we're just going to need to focus on getting that set up for sure, really, before we get too deep into the actual engine simulator. So that's kind of where we're at, and I think we'll be able to do it for sure in this back end. And we could still leverage, with the queue, we could still leverage a pipeline very easily, because one thing, because it's easy, it's arguably, you could say using a pipeline is easier, because depending on how you're approaching your application in terms of, is it going to be asynchronous? Are we leveraging any kind of parallel programming techniques? And if the answer is yes, the pipeline makes it super, super easy, especially because you can pass cancellation tokens, and everything is so self-contained that it can be called. I think it's going to be a really, really clean approach to that. So I'm very excited to explore that, and I just need more time to kind of flesh out a prototype, and that's kind of what you see happening in the videos. It's prototyping this possibility of using the pipeline, and that's why I'm trying to read and just get as much knowledge as I can about this particular model. So why we need time to think about the back end and prototype a couple solutions. I don't want to under stress how important prototyping really is, because you can say one thing and your results can be very different. Prototyping is very, very important, especially for solutions that you don't think will work, because a lot of times it's the stuff that you don't think about or that you overlooked that kind of gets brought out in prototyping. That, or the value in prototyping is that you create this solution and you realize that it doesn't add a lot of value, and you might just go back to your simpler solution. And I think you have to be okay with that. So I think prototyping needs to be looked at just kind of a learning opportunity that you're exploring new technologies that you can use later on if you need to. So done when we have an architecture meeting discussing the research found, and also showing a working prototype. And whenever you hear like working prototype, I think that it's scary, and you think that, oh, I need to make a whole system, at this like expedited rate to get something up and running. That's not really what the ask is, truthfully, for a prototype. The prototype is more of just like a really, really rough proof of concept for a general design idea. Largely you can make anything work in code, but just getting prototype out there and then just getting really rough numbers to see what you're seeing is really helpful. Because that's what we're going to do, right? We're going to make a rough prototype of the pipeline, that's the data pipeline that's going to pass through this engine model, and then it's going to act on it and stuff like that. I'm not actually implementing all the different service calls we have to do, or all the different data transform things we have to do, or any of that. I'm really just setting up the general pipeline and all its links to see if we're happy with the result, to see if we're happy with how the data is being sent through and then returned on the client. And it's just a necessary step, because the last thing that you want to do is implement these, the last thing you want to do is like implement each thing or each service in complete isolation and then worry about the data, because really the data is driving everything. If you have the wrong return type on a service, and you're expecting another service to take to intake another return object type, you're going to have a conflict, and you're going to have to rework something. But if you kind of get this cohesive design, I think, in place first, I think it's going to be really helpful and really powerful. Now, you could argue probably the opposite, but in my opinion, I think that that's what's going to work for us here. So I'm going to go ahead and slide research backend architectures in progress, and I'm going to get another research design architecture meeting up for us to talk about this further. And I think we'll be in a good spot. I really do. I think we'll be in a really good spot. But the research, I might make another research ticket. I might make 2 more. And that's really what you have to do. You have to figure out a lot of the stuff. You got to get your questions answered sooner than later. And that is a very, very large part of software engineering. You need time, and getting the time sometimes can be difficult. But since it's just us, we have that advantage. We can take as much time as we need, and try to create a unique and creative solution to this. So, all right, I think that's it for this stand-up. I'm going to call it here, and I will see you on the next one.